For most of our history, human technology consisted of our brains, fire, and sharp sticks. While fire and sharp sticks became power plants and nuclear weapons, the biggest upgrade has happened to our brains. Since the 1960s, the power of our brain machines has kept growing exponentially, allowing computers to get smaller and more powerful at the same time. But this process is about to meet its physical limits. Computer parts are approaching the size of an atom. To understand why this is a problem, we have to clear up some basics. A computer is made up of very simple components doing very simple things, representing data, the means of processing it, and control mechanisms. Computer chips contain modules, which contain logic gates, which contain transistors. A transistor is the simplest form of a data processor in computers, basically a switch that can either block or open the way for information coming through. This information is made up of bits, which can be set to either 0 or 1. Combinations of several bits are used to represent more complex information. Transistors are combined to create logic gates, which still do very simple stuff. For example, an AND gate sends an output of 1 if all of its inputs are 1, and an output of 0 otherwise. Combinations of logic gates finally form meaningful modules, say for adding two numbers. Once you can add, you can also multiply, and once you can multiply, you can basically do anything. Since all basic operations are literally simpler than first-grade math, you can imagine a computer as a group of 7-year-olds answering really basic math questions. A large enough bunch of them could compute anything from astrophysics to Zelda. However, with parts getting tinier and tinier, quantum physics are making things tricky. In a nutshell, a transistor is just an electric switch. Electricity is electrons moving from one place to another, so a switch is a passage that can block electrons from moving in one direction. Today, a typical scale for transistors is 14 nanometers, which is about 8 times less than the HIV virus's diameter and 500 times smaller than a red blood cell's. As transistors are shrinking to the size of only a few atoms, electrons may just transfer themselves to the other side of a blocked passage via a process called quantum tunneling. In the quantum realm, physics works quite differently from the predictable ways we're used to, and traditional computers just stop making sense. We are approaching a real physical barrier for our technological progress. To solve this problem, scientists are trying to use these unusual quantum properties to their advantage by building quantum computers. In normal computers, bits are the smallest units of information.